Good morning, all of you. What we are discussing in the last class regarding measures of central tendency, we have discussed about mathematical average, right? In this mathematical average, we have a mean, median, and mode. These three are the different parameters under mathematical averages, right? So this mean is again divided into three different types. So the calculation of AM, arithmetic mean for individual series or for discrete series or for continuous series. Okay. So till now we discussed about all these three different characteristics of our mean, that is calculation of arithmetic mean, that you can be denoted with x bar. Okay, so the next important one under this mean is weighted mean, WEIGHTED, weighted. This is called weighted mean. So finally, you may get mean of two types majorly, right? Arithmetic mean and weighted mean. So under this mathematical average, you have mean. So then your mean is again classified into two types, arithmetic mean and weighted mean. Under arithmetic mean, we have read about all these three different types of arithmetic mean calculations for different series or different data, right? So now this is weighted mean. Weighted. What do you mean by this weighted mean? Here I am writing like capital W and capital M. This is called weighted mean. Just write it down clearly. Weighted mean. See ma, for calculation of arithmetic mean, what we did, we have taken one data. This data is consisting of X and F variables and frequencies. Variables and frequencies, right? So with irrespective of highest number or lowest number, we need to calculate x bar, right? So suppose here we have 30, then 20 and 10, and here we have 50 and then 2 and then 1, whatever the frequencies and whatever the variables, with irrespective of its lowest number or highest number, here we need to calculate the variables and frequencies by doing its summation, whatever it may be the method. So this will be done by our arithmetic mean. And in case of weighted mean, see here, suppose here you need to compare salaries of teachers in an organization. Suppose you need to compare the salaries of teachers in the organization. It may be varied from different grades, no? So we have a principal, we have an assistant professor, we have a lecturer, like that the categories are. So obviously the salary of the principal sir is more than these categories, right? So suppose it will be of 50,000, and then assistant professor it will be a 30,000, and for lecturer it will be a 20,000. For example, I am saying you. So these you may consider as variables. These we may consider as variables. So with respective frequencies are 10, 50 and 30. See ma, here you just take it out, these three values here. 50 stands for 10, 30 stands for 50, 20,000 stands for 30. So see here the highest amount will be a 50,000, but the frequency will be a 10. As compared with these two, this frequency value will be less, right? So with irrespective of these variables and frequencies, here there is a need to calculate some weight. There is a need to calculate the weight. So by the means of this weight, you can give equal importance for variable, or it may be a frequency with irrespective of highest or lowest number. Did you get? See, in case of arithmetic mean, once again I am telling you, first you understand the concept, then it is very easy to do the problem. Suppose what is the data for previous problem? Any one of the data, either it may be a class, interval, or it may be a classes. Class interval, or it may be a classes, right? So you have 10, 20, 30, 40 and 50. These are comes under variables. And what is the respective frequencies here? 5, 10, 25, 30, 40, 45. So see here also the number is increasing from small number to big number. That means it will be presenting the data in the ascending order. And in case of frequencies also, the data will be present in ascending order only. There is no zigzag in the numerals. So, but here, what finally the conclusion will be? We are giving importance to our summation only, with irrespective of highest or lowest numbers. So this class is representing this frequency and this class is representing this frequency. So when we are going to compare all these 6 numbers, we are not giving the importance of calculating all these components individually. Simply we are doing the summation. That's what sigma f or sigma fx we have done in the previous problems. That is what the calculation of arithmetic mean. But in case of weighted mean, you need to take proper weightage of the data. Either it may be a variable, or it may be a frequency, or it will be present in the smallest number, or the number will be the highest, with irrespective of their exact components of the variables versus frequencies. So once you will do the problem, you can understand it very easily. But you need to write down one major point. Just write down. You just write down, for computing the arithmetic mean. Computation is nothing but for calculation. For calculation or computation, whatever it is, you can write it down. Okay. For computing the arithmetic mean, or ARE, based on the assumption that all the items in the distribution are ARE of equal importance. Why the point has become like this? We are calculating the summation of the variable or frequency. So to calculate the summation, or to calculate the addition, to add the all variables, we need to add all the components which are present in our data. Suppose we have 8 values, or we have 2 values, or we have 6 values. We need to add all these values. That's what in case of arithmetic mean, based on the assumption, all the parameters or all the variables will place an equal importance, where the relative importance of all the items of the distribution is not same. See, once again I am reading. For computing the arithmetic mean, are based on the assumption that all the items in the distribution is nothing but you have n number of values. This is what called as distribution. In this distribution, are of equal importance. We have n number of characteristics. These n number of characteristics will place an equal importance while calculating the arithmetic mean, right? So then, however, where the relative importance of all the items of distribution will not be the same, So here we are not giving any importance to the weights. Simply we are calculating or we are doing sum. That's it, right? If next point, just write down. If some items in a distribution, if some items in a distribution are more important than others. Suppose if you feel like your second variable is most important than first one, because here we have an highest frequency. Likewise, in such cases, what we need to do? See here, in some items in a distribution are more important than others, then THEN, then this point must be borne in mind. So we have a point in our mind, like if any of the variable present in the data may be placed an important role. Likewise, the point has been arised from our minds. In that times, in order to get average of the distribution, write down, in order to get average of the distribution, comma, proper weightage is to be given to various items. Are you getting my point? See, you have n number of variables or n number of respective frequencies. Suppose you are having one doubt. This 4 is placing a major role for calculating all these summation, or this 4 is having highest frequency among these 3, or this 4 is having lowest frequency among these 3. So likewise, if the question arises from your minds, so then what to do? You need to do as per the weights of the respective variables. So this can be possible only through the weighted arithmetic mean. So just check it out, your sentence. I am reading again. If some items in a distribution are more important than others, then this point must be borne in mind in order to get average of the distribution. Where we are getting the average of the distribution? In case of general arithmetic mean. In order to get average of the distribution, proper weightage is to be given to various items. So the next point will be, just write it down, the weights attached to each item, the weights attached to each item being proportional to the importance of the item in the distribution. See, you have X and F and weights. Here I am taking only 3 numbers for easy understanding. 3, 8, 10. So the variable 10, the accurate weight of this variable will be 15, and then it will be a 10, then it will be a 30. Okay, suppose the values will be like this. So all these variables which are present under X column will give the equal importance to their respective weights. See here, 10 is giving importance to 15, 30 is giving to 10, and 50 is giving to 30. So these variable values with respect to the weights are to be proportional. This is what the proportional symbol. What is this? This is called an inversely proportional, right? So, but here what I am telling, this is proportional to the weights. What is proportional to the weight? The weights attached to each item is being proportional to the importance. That means weights are, just write down, weights is proportional to the importance of variable. Importance of variable. In the textbooks, it is not that much clear. So the definition of this weighted arithmetic mean, you just put a subheading like definition. The weighted arithmetic mean may be defined as, the weighted arithmetic mean may be defined as the averages whose component items, are being multiplied by certain value is known as weight. So here you need to do some multiplication for getting a weight. So the variable and the f values, you need to get some fx values. Here, this is not call it as a frequency. This will be call it as the weights. So here you need to do x into w. See, in case of the problems, they used to give variable values. Those are of x. And the next one is weights of that particular variables. So what you need to do for getting the proper weights, you have to do multiplication between the variable and with the respective weight. That is what? X into w. Then you will get some sigma xw. That is a different thing. So first you need to remember up to this mark. So they used to give some variables and they used to give some weights. So we have to do the multiplication for getting the proper weights. So this is nothing but the weights. And the aggregate of the multiplied results and this aggregate of the multiplied results, those are xw values, and the aggregate of the multiplied results are divided by the total sum of their weights. While doing problem, it is important to understand. See ma here. And the aggregate of the multiplied results are divided by the total sum of their weights. That is sigma w. That is what? Total sum. If, next point you just write down, if x1 comma x2 comma x3 and so on xn are the variables and with respective weights of W1, W2, W3 and so on Wn assigned to them are each weight is indicating the relative importance of each given values. So see here, this is what our variable and it is giving the importance of our W1, or W1 is giving importance to the variable. So likewise, X1 is representing W1, X2 is representing W2, Xn is representing Wn. So this is called the relative importance is given to each of the values. So this weighted mean can be divided into two different methods, direct method and you have shortcut method. Direct method and you have shortcut method. Once you will do the problem, you can understand it easily. See, first you just take it out, this direct method. Write down direct method. Direct method. Just write down like a point. In this case, each value of the variable, each value of the variable, you just write it down in the bracket as a x. In this case, each value of the variable is multiplied by its what? By its weights. And the products so obtained or aggregated is multiplied by its weights and the products so obtained are aggregated. See what it is saying, you have an x values and you have an w values. When you are going for multiplication, the product what you obtained is here, it will be a aggregated product. So the formula will be x of w, weighted mean. So this is what our arithmetic mean denotation, right? So this is x w bar, weighted mean is equals, how the formula will be, x1 w1 plus x2 w2 plus x3 w3 plus so on xn wn, which will be divided with summation of weights. That means w1 w2 so on wn. So this is the formula to calculate a weighted mean by direct method. So here we are doing the multiplication of our variable with respect to the weights, which is divided with the summation of the weights. Did you get what I told you, the definition? Then it will be written as sigma x of w divides with sigma w. This is called the summation. Sigma is called the summation, right? So this is the summation of this and sigma w is w1 plus w2, like that. So if you do one problem, see, in this case, the calculation of weighted mean, they will give the variable values and the weights. So for that, the calculation is easy, right? So this is what the formula for direct method. And the next one is shortcut method. Just do at a time, shortcut method. This is simple, no? That's why there is no problem. Shortcut method. In this case, you just write down, in this case, we assume an average. We assume an average and take deviation from where? Assumed mean. I think you already studied about how to take the deviations from the assumed mean in the shortcut method of calculation of mean in the discrete series and continuous series. We have a shortcut method, right? So in that also, we are going to calculate some deviations. Those are small d. What is the formula? X minus a. X is the variable and a is an assumed mean, right? So in the same manner, here you need to calculate the deviations from the assumed mean. So the formula will be xw bar is equals aw plus sigma w into dx divided by sigma w. Just write down the formula. Xw bar is equals to aw plus sigma w into multiplied with dx divides with sigma w. Here xw bar is weighted am. This is what? Assumed weighted mean. Assumed weighted mean. Assumed weighted mean. Dx is deviation of items from the assumed mean. Dx is deviation of items from assumed mean. W is weights of various items. W is weights of various items. See, once again I am telling, x bar is the weighted arithmetic mean, AW is the assumed weighted mean, dx is the deviation of items from assumed mean, small w is the weighted various items, weights of various items. If you write down one problem, it is easy to do. Write a problem. Calculate the simple weighted arithmetic mean. Calculate the simple and the weighted. Simple. So here you need to calculate both simple and the weighted arithmetic means from the data recorded in a Anganwadi school, whatever it is, just write down, in a school of GHMC limit, and comment on the calculated means. They won't asking us the result. They are asking us to comment on the means. Why they are giving the question like that? Here they are asking to calculate us both simple and weighted arithmetic mean. First we need to do calculation for both the things. Then we have to compare, or we have to give some conclusions, right? So just write down designation, weekly salary, and strength of the cadre. Designation, under designation we just write down principal, not principal, vice principal, teachers, clerical staff, lawyer staff, right? Are you writing?
Yes, ma'am.
Okay. Principal, vice principal, teachers, clerical staff, lawyer staff. And weekly salary of principal is 1500. Vice principal 800. Next one, teachers are 500. Next, clerical staff 250. Then lawyer staff 100. The strengths are 10, 20, 70, 100, 150. So here you just make a tabular column with 6 columns. With 6 columns, you need to plot the table. That is what the week